My name is Delilah Miller, and I am working under Dr. Farmer. I will be presenting the fourth organic molecule found in space. When talking about space, you have to specify what region of space you're talking about. Are you talking about the space between the Earth and the Moon, the Earth and neighboring planets? In my case, I am talking about the interstellar median, which is the space in between two star systems in a galaxy. We have our sun over here, and our closest neighboring star is Alpha Centauri over here. So the interstellar medium is this area over here. Methylamine radical is the organic molecule that was found. It was first discovered by Swings and Rosenfeld in 1937 and was later confirmed by McKellar in 1940. It was discovered using a ultraviolet and visible spectrophotometer in the ultraviolet and visible region. When I'm talking about ultraviolet and visible regions, I'm talking about the light spectrum. So we have the light spectrum up here, and the small region right here is the visible light. And usually for UV vis, they range between 200 and 800 nanometers, so over here in ultraviolet light to visible light. And how UV vis works is light is shined onto a sample, and the sample either absorbs the light or it doesn't, and that absorbance is how the sample is identified. It was discovered using a very, very powerful telescope. At the time, you needed one of the most powerful telescopes was the Coupe spectrograph at Mount Wilson Observatory. The reason they needed such a powerful instrument is because the ISM is very far away and that requires a high resolution. So McKellar found the molecule 7 times between 3100 and 4300 angstroms. And the reason his discovery was so important is because it proved the abundance of hydrogen in space. At the time, they knew that, or they had an idea that there was a large amount of hydrogen in space, but it wasn't necessarily proven yet. So on this graph, you can see that hydrogen on the logarithmic scale is very abundant compared to the rest of the elements. And the reason that a molecule can go against the octet rule is because it doesn't have much of a choice. The ISM has a density of 10 to the negative 4th to 10 to the 6th particles per cubic centimeter. In comparison to air particles in the sea level, the Earth has 10 to the 19th particles per cubic centimeter. So it doesn't have the ability to come across a whole lot of molecules as often as it would on Earth. On Earth, it could attack a lot of the molecules found in the atmosphere, even dinitrogen. And it doesn't have that ability in the ISM. Thank you for watching.